Uh, had a good rest from yesterday to today. Now gonna start the second day. This second day, we have 4 or 5 chapters, depending on the time. 4 is good, 5 is awesome. Okay. Uh, oh, excuse me. We're going to start the chapter with policy layers, which is kind of a continuation from the last chapter, uh, which was managing policies, right? So, can you hear me well? Everything's good? How's the audio for you? Yes, no? Well, I can see my microphone good here. Okay, sounds good. Awesome. So let's begin. So, policy layers. What is this? If I pass this slide, you're gonna see some square images, right, with some arrows, basically, right? So I don't like it too much. Well, I could explain here, but I'd like to do it drawing in a whiteboard. So let me get my whiteboard because we have whiteboards, right? So let's talk about layers. Right? First of all, you have 2 types of layers. The first one is called ordered, and another one is called inline. Okay, so let's explain this in this whiteboard. So by default, what you have when you enter on your firewall is something like this, right? Let me enter on my lab. Where is my lab? Where is my mouse? Oh, here. Okay, let me put here. I think it's a little bit big. Yeah, true. Okay, so if you come to the lab, you only see one list of rules, firewall rules, right? Like this list here, right? You only see one list, which is the default, right? When you are using checkpoint firewall, that is the default. So in our whiteboard, we have one firewall list of rules, okay? And you have your rules here, rule 1, rule 2, 3, 4, etc., right? Layers basically is the capability that you have to create more than one list, okay? Rule list. Why? Because you want to do some separation of duties, for example. What I mean is you can create on your first rule list, this one, you can care only about layer 4 rules, firewall rules, which means that you are only dealing with IP or networks and ports, right? Source, destination, port, accept, deny, drop, right? That's it. You're not dealing with layer 7 features. Okay, why? Because you want to add a second layer with a layer 7 feature. For example, app control. So all of your rules related to app control would be here. Okay, so let's say Facebook, Twitter, YouTube. Okay, um, and that's it. That's how it works. But what happens when you create this kind of scenario? What happens in the inspection, right? The packet comes, let's say there is a guy here, user, regular user, okay, that wants to reach a server. Let's say that this server is the YouTube, okay? So the packet will reach the file and we'll start with the first layer. The first layer is this one here, the network layer, which deals with layer 4 traffic, right? So there will be the top-down inspection as normal. If there is a match in the rule, that rule will be used and the action for that rule will be applied, right? Either accept or drop, okay? So there was no match here, go to the next one. There was no match here, goes to the next one. Let's say there was a match here. And the action for this match is accept, okay, hypothetically. What happens with the traffic, well, I mean, with the inspection? Well, based on this very first layer, it's okay. The inspection concluded that you can, traverse the packet, but there is one more, right? The second layer. So now the inspection gonna happen here, the second layer, and then the process repeats. So let's say, is this guy accessing Facebook? Well, no, so there is no match. Is this guy accessing Twitter? No, go to the next one. Is this guy accessing YouTube? Yes. Okay, what's the action? It could be allowed or denied. So let's say it was allowed. Okay, cool. The traffic is allowed. And then he accesses the results, the YouTube in this case, right? Note that the inspection only goes for the next layer if in the current layer, the action, the rule action is an accept, right? What I'm trying to explain here is, let's say that this guy opened another connection, right? But this time he's trying to access Netflix. Not exactly Netflix, anything else, right? Doesn't have to be Netflix, anything else, right? Because it doesn't matter what he's trying to access. And then there'll be this first layer of inspection, right? The no match here, go to the next one, no match here, go to the next one, next one, next one. And let's say there was a match and the action for that match is a drop. Okay. As this is a drop, there is no need for the traffic check, right? The next layer because it's dropped already. It only goes to the next layer if you have an accept, right? So this is policy layers, very basic explanation, but you can develop more. You can add more layers if you want. So let's say that you don't have 2 layers, you have 3. Wait a second. Okay, I'm back. So let's put a third layer here. Oops. Okay, and let's say that this layer is web filter. Okay, and now you're controlling like finance, traffic, shopping, um, I don't know, whatever, right? Let's put one more here, news. Okay, and now this user is trying to access, let's put ESPN. Okay, it's the same process. It starts here. It's gonna check which rule that applies for that traffic. Usually, network rule would be something like from that internal network to internet accept. It should be something like this. So it would be the same rule for the YouTube example. Then the traffic goes to the second layer. Again, okay, second layer. Is it a Facebook? No. Is it a Twitter? No. Is it a YouTube? No. So what's next? Well, usually you have what is called cleanup rule, remember? So that would be a cleanup rule here. But in this case, it's recommended that the cleanup rule use the accept action. Why? Because usually when you are dealing with app control or even web filter rules, if there is no match in any rule over there, it means that the guy, the user, is not trying to access any of those resources, it's something else. So if it is something else, why should I block him, right? It just means that it's not an app control traffic that I'm dealing with, okay? So it's recommended to use a cleanup in this case. Okay, so we'll have an accept, and then it goes to the last layer, okay? And it's gonna check against finance is not finance, right? Candles, right? Or sports. Okay, let's say it's news. Accept. Then the traffic is allowed, and he can access his us, in this case, ESPN. That's how it works. The ordered. Okay, this is the ordered. And another thing about ordered, not ordered, but layers including inline, is that the one flow. Okay, don't have different rule lists, right? It's all inside the same rule list. So let's say you have your first rule here. Oops. The second, the third, and in the third, the action you call an inline layer. Instead, you put accept or drop actions, you call an inline layer. And when you call an inline layer, it means that you're going to have a 3.1, 3.2, 3.3, whatever, right? Rules. So this is like a parent rule, and these ones are child, right? Rules. These guys here. Let me fix this. Okay. And of course, the list goes on. 4, 5, 6. Okay. No problem. What is the difference between the ordered and inline? In ordered, every rule that you have a match with an accept action, the traffic will be sent to the next layer, always. Okay? Doesn't matter what kind of rule is being matched. So let's say you have a rule that allows SSA. There is nothing to do, SSA, there is nothing to do with Facebook, Twitter, YouTube, finance websites, shopping websites, news websites. It's SSH, not HTTP or anything else. But this is ordered. So there will be a match in the first layer. This match has an accept action. The traffic goes to the following, to the next layer. Is going to be inspected, even if that has nothing to do with that traffic is going to be inspected, right? It's going to reach the cleanup rule, which has an accept. Then it go to the next one. Also, that is nothing to do. So there will be a cleanup here as well. Okay, and then a final accept. So you spent like 3 layers to allow SSH. If you use the inline approach, so let's say this is the SSH rule, right? And there is an accept. That's it. It's over, right? The traffic goes. Let's say there is a router here that you're trying to do an SSH. Okay, that's it. There is no extra layers. Why? Because the only way to go to the layer in the rule 3 is if you have a match in the rule 3. Okay, so let's say you have an HTTP rule. This rule is an HTTP, right? And the sublayer is exactly Facebook and I don't know, YouTube. Okay, and this one is the cleanup, right? You can see this structure replicates this structure here. It's the same effect, basically, but the difference is the system will only call this layer if the match happens in the rule 3. Any other rule that you have a match and the action is accept, that's okay. There is no way to call the next layer, okay? And this doesn't happen as well, right? Because this is the same as returning to the previous layer. So if there is no match here, let's say there is no match on 3.1, 3.2, or 3.3. Oh, I'm sorry, 3.1 and 3.2, and they have a match on 3.3, right? The traffic goes out. Okay, it's not going to let to rule 4 because rule 4 is the previous layer. Okay, that's how it works. But this is basic stuff. You can make it more complex. And that's where you have to be cautious, right? Because you can create nested layers and also combined layers. So you can have something like this, for example. Let's say there was a match here. Let me put Facebook here. And let me change this first one for Netflix. Okay. All right. It reached Facebook. So if there is a match on Facebook, it calls another layer. 3, 3, 1, 3, 3, 2, 3, 3, 3. Why? Because if it's Facebook chat, if it's Facebook marketplace or whatever, right? You want to check. Okay. So this is now this is another child. So this is a child for this parent, but this one is parent for this guy. And you can have like a 3, 3, 3, 1, right? And then a 3, 3, 3, 1, 1, and so forth. Okay. You can also, and as you can see, it's becoming complex, right? And you can also add and combine inline with ordered layers, right? So in this case, there will be another set of rules here about some things. I don't know, let's say content awareness, which is another blade. Okay. And if there is a match here, goes to this guy. If there is a match here, go to this guy. If there is a match in the inline, it's gonna call the child rules, right? And let's say there was a match in the YouTube. Okay. In the YouTube, there is no sub rule, right? There is no another inline layer. So it goes out here, but there is a second ordered layer. So yeah, you have to come here. Okay. In the case of Facebook, it's gonna reach inline, then gonna reach Facebook, then it's gonna reach the sub layer, then it's gonna reach the sub layer, then the sub layer, and finally it goes to the next ordered layer. So as you can see, you can create a good mess on this with this feature. Okay. And how can we create this on our on a smart console? So let's take a look on our lab, right? Because right now in our lab we don't have anything like this. Okay, we only have one rule list. That's it, nothing else, right? We are not using layers right now. Okay, so in order to use layers, oops, sorry, you must come here to manage policies, managing policies and layers. Okay, click here. Then we can go to layers and create a new layer. So let's say this layer is app control, and I'm gonna use app control blade only. Okay, and click OK. Now what I'm gonna do, I'm gonna add this layer to one of my policy package. Remember, policy package is the whole set of different policy types that I'm using for a firewall, right? So we come back here to the policies, which we have our policy packages, and let's add to the standard. Okay, we come to the standard, and over here you have the access control type, and there is no layer here. What? Oh, okay. Let me create here right away. app control 2, just not have a conflict. It was not showing because I didn't publish, so I'm creating on the fly. It's the same effect. All right. As you can see, you have now the network layer and the app control layer. Okay. If I click OK, then close, you can see here that it's different now. So it's similar on what I did, but what I did is from left to right. In the Smart Console, it's top down, but it's also, you can see the order, right? And that's it. You can see here the app control layer. The first thing they're usually going to do is change this to accept, because this is a layer dedicated to a specific kind of traffic. Okay. And you can add rule as any other rule, right? And as I said, you can combine rules. So let's say that's the second rule here. Call an inline layer. So basically, instead of choosing action here, I come to inline layer, new layer, and let's put something else. Let's put Facebook details like chat, marketplace, gaming, live streaming, or whatever. Okay. It would be like app control is the same. And as you can see, we have a second set of rules. And as you can see, I can add another inline layer, right? To become messy. I'm playing around here, okay? Don't worry. You won't do this. You wouldn't, right? I'm just showing that you can nested the rules. And usually you have a lot of rules, right? You don't have like 5 rules like this. You have hundreds. So you must be very careful when you are creating this nested rule set, or even this combination. Okay. And as you can see, you have a lot of different options. All right. And also I can add a new ordered. So let's add a new ordered. We come to the standard, and you just click on the plus sign here, another layer. There's another layer. Let's say it's content awareness. Let's say credit card inspection. Oh, I'm gonna put this as shared. I'm gonna explain why I'm doing this. So I just checked the sharing here. Okay. And now it's in here. I'm saying that this layer is a shared layer. Okay. And I can change the order. Right. Let's say this guy is the second one. Click OK. See, it's changed. Now this layer is the second one, and you can see the symbol for shared. What is this shared? Means that I can use this layer in any other policy package. So let's say that this credit card inspection rules must be applied for every file that I have in my company, right? Every branch, every place, I have to use this layer. So instead of creating multiple layers to do the same thing for different firewalls, I create only one layer and I put this as shared layer. So in my second policy package, let's say this is my branch firewall, right? I can just come here and add the same layer. And as you can see, it's in here. So everything that I do in this layer is gonna be applied for every uh, policy package that is using that particular layer. And that's it. This is all about layers. Okay. What is the benefit? Separation of duties. You can have one layer to deal with one kind of traffic, a second layer to another kind of traffic, a third layer to another kind of traffic, and so on. The strategy that you're going to use depends on what you want. You can use either ordered or inline or both. If you're going to the inline, you can nested. I mean, you have a lot of options. So to avoid problems, the best that you can do is plan in advance what you want based on on your needs, right? And from that, take the decision if it's going to be ordered or inline or even both. Okay, that's it. That's all about layers. So let's go back to the slide here. As you can see here, oops, this layer is shared because it's being used by two different policy packages. This one is probably not shared, and this one probably is not shared as well. Okay. Over here, ordered layer, inline layer, I show you this, right? You can use both, one of them, or the strategy that you want, right? The explanation here is about ordered. It only goes to the next layer if you have an accept in the current one, in the previous one, okay? And you must go through all the layers if you're using ordered layers, right? So it's impossible to have an accept here and the traffic goes away. No, you have to come to the third layer, okay? This is an example of the inline layer, right? It's just calling that second layer, but it only calls if there is a match in this rule. Layer, rule 1, 3, 4, 5, it doesn't matter, right? It won't affect and it won't call that layer. Okay, and that's the point that I told you before you begin. Plan, right? Check your needs and check what is the best strategy for you, because if you don't do that and try to do it as you create, as you are going, it can become very messy, very complex, and the troubleshooting can be very difficult, right? So plan in advance, right? Yeah, that's the point, plan in advance. Okay. And it's just like building blocks, right? What he's saying here. Okay. What else? The management, right? It goes from the manage policy layers screen. I show you this, right? You can check where the layers are being used, right? So for example, this one here is being used on 3 different guys. Okay. So you can check if it's a shared layer or not, or whatever. Okay. This is just the explanation. Okay. Just the explanation. You can filter to show only the shared layers if you have a lot of layers, right? Yeah. Yeah, this change of order only applies, of course, for the ordered, right? Not the inline, okay? You can modify any layer the way you want. You can enable a blade in that layer or disable a blade in that layer, right? You can export them to a CSV file. That's good because if you need to export this and send to someone else to review, or you are reviewing from your customer and you ask this CSV file from your customer to check what's happening, you know, um, you have some options here, okay? Adding the inline layer that show you, just go to the action column and go to the inline layer option. Every layer that exists will appear. If there is none, just click new layer. Okay. Uh, Best practice. Well, it depends on what you want. Usually, layer 7 inspection layers, like these two guys here, content awareness and application, it's good to have them as shared because usually these policies applies for every file in the company and you are not using network addresses. You are using categories, you are using application names, you are using credit card patterns, this kind of thing. So as you are not using layer 4 information, you can share this to any of your policy packages. Okay. And that's it. 2 labs for this. One lab is 6.1 related to ordered, 6.2 related to inline. Let's take a look in the book. So we are here, policy layers. It starts on page 342 and it goes until 395. So it's roughly 50 pages. Okay, 50 pages, we can put like 50 minutes. Okay, 50 minutes. I didn't remember that it was so extensive. So let's take a look here. Yeah, you are enabling the blades. Oh yeah, I have a lot of things to do here because I create a whole structure, right? A whole structure about app control URL and content awareness. Okay. Oh, by the way, let me check one thing here. Okay, no problem. I think that was on policy 5. Yeah, on policy 5, you created, on lab 5, you created the Bravo security policy, right? So in order to do the lab 6, you must have finished lab 5.2, right? It's sequence, okay? Because you're gonna establish communication with the big gate. The big gate is already installed, right? But you need to establish SIG, this kind of thing. So if you haven't done this guy, it would be difficult to do lab 6, okay? Anyways, right now is 9:40 with 50 minutes. It's 10:30 with 10 minutes for break. 10:40, 1 hour, right? So let's input here labs 6.1 and 6.2 plus break. Return at 10:40. All right. So you can start your lab. Good luck. Good lab for you. Good break. If you have any problem, just let me know. I will be on mute here. I'm just gonna get some coffee and water, but I will be here. Okay? Just leave a message and I return to you. I stop sharing now. I'll be mute. Yep. See you at 10:40. Oh, there is a file update. I prefer checking on smart update than checking on smart console, just because I'm old.
Yeah,
But
we are
anyways, I'm pretty
doing.
sure that whatever shows here is good. Okay. Well, the big gateway has a trial license. So that means that you don't need to add a license on this if you don't want. Okay. But if you really want, we can just come here. There is no unattached license. Okay. So what you can do is we can add the license to repository. This guy here. Okay. I know what's happening. The three licenses are attached to a gateway. So a gateway are using them now. So let's remove one of the a gateway,
Okay. So it could be
detach.
because I had a wrong license file for a gateway before.
Yeah, it could be, but no
Hmm.
problem. This is a controlled environment, lab environment. We can do whatever we want. There is no problem, right? So now we can attach and 10.1.101, and we can attach here. And now we have a license to a big gateway. Again, it wasn't needed. Was no need for this because we have the trial.
Okay.
But if the lab asks to add the license, there you go. You have the license now.
Okay. Thanks.
No problem, mate.
Let me see. I
Going.
think I may got an issue here. Let me see. How come I don't see now? I'm running lab. Okay, the lab 6.1. Okay, at the portion at the. Let me see at the page number 357. Right. I supposed to see firewall policy, right? But I didn't see that on my port.
357. This page?
357.
Which page? Is this one?
Yes. 357. Yes.
Okay. So it's asking to enable these blades, right? On
That should be fine.
BGW.
Now license address should be fine. But when I go to, yeah, okay.
Oh, it's locked. Okay. Your gateway, there is a lock here. Okay, which
Because
means
I did somewhere using other profile to user.
yeah, which means that you probably have more than one session. So let's take a look here. Probably this session or this one of these two sessions are locking you. These
Okay.
ones. So you can see 48 changes, right? Let's publish this
Okay.
first, and then I'm gonna disconnect the other two.
Very good. Very fast. The good thing that you go to these trainings so I can understand more how to gel all together. So I did some firewall big point before, yeah, but not that get used to that, not very familiar with big point.
Yeah, it's still locked. Yeah, no problem, mate. It's oh good. Okay, it's still locked, so I'm gonna get this session take over. Okay, now we are with this session. Let me publish this again. Let's see now how it goes. Okay, now it's free.
Oh, okay. Okay,
Now
thanks
it's
a lot.
free.
Let me continue it.
It's important to understand what happened. There was a second session somewhere in some time that was not closed totally,
Mm.
and this session was locking the big gateway. So you were not able to do anything because
Yeah.
remember when you log with a session with one account, everything you
Right.
do inside that session, that was
Mm.
what was happening. So everything was inside that session, you could not do anything without releasing or publishing what that session was doing. So that's what's happening.
Okay.
Okay, go ahead,
Okay.
mate. It's all yours.
Thank you.
All right, people. Right now it's 10:43. Our return would be at 10:40, right? So let's do this. I know that people are still doing some labs, like Shan and maybe someone else. So I'll give you 10 more minutes. Not 10 more minutes. Let's say, okay, let's round up to 11. Okay, 15 minutes, basically. Okay, so new time is 11. So if you already have finished it, you are free to get a coffee, no problem. But at 11, we are going to resume the lecture and talk about the next chapter, which is chapter 7. Okay, so give you a little bit more time. Okay. Oh, good. The timing is fine. No worries. Um, so let me share my screen. Let's talk about the next one. Let me just find where is the button. Okay. So yeah, what we have so far since the beginning, right? We talk about what is checkpoint, the different kinds of firewall, what is the stateful firewall, the firewall checkpoint firewall components, SMS, gateway, smart console, the different kinds of deployments, the SIC trust communication, um, the licensing, how you can create rules, and then how can you add layers to these rules, right? And now, how can we improve our policies using application control and URL filtering, right? So basically, this is one blade. It seems that it's two blades, right? But this is one blade only, right? That cover both features, okay? They are very similar to each other, but the way they work is different. Why? Well, application control basically inspect payload, right? The packet payload. And based on a series of patterns, patterns basically traffic patterns, like right the payload, it comes one packet like an HTTP request, and then there was another packet with HTTP response, and then there was another HTTP request with another kind of pattern inside it, and so on and so forth. So this sequence of packets is used by the app control feature to detect which application is being used. Okay. URL filtering, as the name suggests, is the URL, right? So that means when someone comes to the gateway, right? Let's say there is a user here trying to access whatever page, let's say ESPN, okay? The gateway will ask, oops, sorry. Oh yeah, the threat cloud, right? Asking, okay, what is the category of this URL? Maybe the URL is espn.com, right? Or .com.au or whatever, okay? And then the threat cloud, which is a checkpoint cloud, right? Is going to answer, hey, this is, I don't know, sports or news or whatever, right? And the gateway, will check what is the action for this category in the rules. That's it, right? So URL is a little bit lighter than the app control, because the app control, it has a local database, appdb, that you need, oops, that a little bit better, that you need updates, frequent updates, right? Also from the threat cloud, okay? And these patterns are stored locally. So you have to check different patterns, and this amount of patterns will define what is that What is that application? Some kind of resources applies for both app control and URL filtering. For example, YouTube. YouTube can be controlled by app control or URL filtering. Okay, Facebook is the same, Netflix the same, right? But there are some applications that's only detected by app control. You cannot detect by URL filtering. For example, Ultrasurf, torrent applications, torrent software, right? So this kind of software is only detected by application control feature, not URL. Okay. Another thing that is important to mention here is, let's say again, YouTube. Okay, YouTube can be used on both, right? URL or app control. But app control gives you more flexibility because as URL only checks the URL itself, so let's say YouTube, right? This is just a binary control, is either allowed or not. Okay, that's it. But on app control side, you can have like you can allow like YouTube videos, but you can deny YouTube channels, not channels, the uploads. Okay, let's say you have a channel and you want to upload a video. Oops, it's not a T. Okay, let's say you have a channel, you want to upload videos, right? So you have to go to a specific session on YouTube portal to do this task. With app control can detect these small differences inside the YouTube. The same goes to Facebook, for example. Okay, the same goes to others um, um, social media. Okay, so you have a granular control with app control, although app control is heavier. Okay, URL filtering is more like allow, accept, or drop. That's it. Okay, so let's take a look on, for example, some cases. Okay, that's exactly what I was saying, granular policy. Okay, you can use the applications, the app control, to check which applications is traversing your firewall. You're not exactly blocking them, but your rule will allow to detect these applications. These applications will be logged, and you analyzing these logs, you can see, well, there are some users that are using torrent on my company, or there are users that are using VPNs in my company, right? So this kind of detection is good because it gives you visibility. And with this visibility, you can take proper action, give better control, right? Start blocking or whatever. Okay. And you can, and if you are using identity awareness, which is our next chapter, uh, you can detect who is doing what, because identity awareness is the user detection. Okay, so you can connect who is accessing YouTube in different times throughout the day, right? And you can check if that was allowed or not. Okay, so basically, these blades gives you a better control and visibility on what's happening on your network, right? And this is important, of course, because nowadays we have different laws for different countries, and you have different resources that can be liable, right? You cannot access this some websites from your company, right? It's not a good thing. Okay, so for example, here you have uh, some applications like VPN applications, proxy applications, right, that people use to mask their data and not be detected. So wait a second, something in my headset. Okay. So when you use application control, you can detect people that are using this kind of application, right? And of course, if someone is using this kind of application, probably it's not for, make a donation to save someone, right? Is using this to do something not exactly acceptable, right? I'm not saying that it's committing a crime or something, but something that is not acceptable by company policy, right? So you don't want this, right? So it's a good thing to have app control, okay? And also, this is the base, more than 9,000 of application, more than 250,000 of social network widgets. Widgets are those small areas inside a social network, like channel management on YouTube, right? Your channel manager, you're uploading a video, or gaming on Facebook, or chatting on Facebook. These are all what they call widgets, which is small pieces of the application in that particular social network. So it can detect all the small pieces of applications in a social network. Okay. And these are the benefits. I think it's self-explanatory, right? You want an application control, you want aware of URL filtering in some extent, right? Because you want to have visibility. You need visibility, right? It's not networks nowadays, not only IPs and ports, right? You can tunnel a traffic using port 80, right? Someone can use a torrent that's traversing packets using port 80, port HTTP, right, to download games, videos, applications, whatever, using your bandwidth, right? So this is not exactly a good thing, because you are taking a risk to get some malwares and spread this malware inside your network, right? So you need this type of feature, okay? And every security device nowadays offer something similar, some kind of app control, some kind of URL filtering. This is a very common thing, okay? And with checkpoints, there is no difference, right? So in this case here, you can see there is a rule where every network from, not every, the internal network from B and from A, because this is our topology, you have the alpha side and the Bravo side. So it doesn't matter which network, both of them applies. Going to the internet, if they are accessing Facebook or YouTube or Amazon, and as you can see, these icons, this is app control. How do I know? Because URL filtering use categories, right? So when you see this kind of icon, it means they're using app control, okay? So what's the action? The action is ask. It's not accept nor drop. What is ask? What the hell? So let's take a look in our lab. If you come to our, oh, wait a second, this is not mine. This is mine. Let me close this. This is from Sean. Okay, this is mine. All right. So when you come to your smart console on security policies, if you go down, you can see this icon here, user check, right? Let's click on this. And as you can see, you have some, let's say, profiles, okay? And basically, these profiles are block pages, kind of block pages. Okay. And this is the layout of the block page. So let's get the company policy ask. Okay. Which is exactly what is inside in our slide. So the ask is basically exactly what it's saying. It's asking. So when a user try to access YouTube, Facebook, or whatever, there will be this page before opening the page itself, basically saying, well, you are trying to access this page. Are you sure you want to proceed? Because maybe that is not exactly a good time to do it, right? Maybe it's you have a lot of job to do, a lot of tasks to do, but you still want to, I don't know, watch a video, right? So this gives you an opportunity for the user to give up, okay? And if a user is certain that he want to access that particular resource, that page, he's gonna check, right, this and click OK, right? And then the page opens. But when he does this, a log is generated, getting his IP address, right? And when he did this. If you are using data warden, it's gonna get his name as well, his username, right? So you are registering everything, you are recording everything, okay? And of course, you can change this, right? You can add your logo if you want. You can change the language. There are some default languages here, right? But you can come, click on the pencil, and when you click on the pencil, it's basically HTML editor, right? So you can come here and put another image, right? Add logo. So you can come here and add new image, and you can get any image that you have. I don't know if I have an image here. No, nothing. Nothing. Yeah, I don't have anything here. But anyways, I think you got the idea, right? You just get your logo from your company, your customer company, whatever. You can change here from application control to any other title that you want in any language that you want, right? You do all the customization, click OK, and that's it. It's gonna be, let me change this. It's not application control, it's control application. And you can just um, put like I am watching you. Okay, click OK, and I need to publish this guy. I don't know if the publish is going to work because I have done a lot of different things since yesterday, so I have no idea it's going to work well. Let's see. Well, it seems good. Okay. Yeah, I am watching you, right? So yeah, you can change it. So you can get this kind of um, action and put in the rule. For example, block message, right? You don't want to allow the guy to access the page. So you can put, hey, you cannot access this right now, right? So everything you see under user check are basically actions that give some interaction with the user, okay? So let's see, there is a question here. Um, the database signature detect on payload or common port. The database signature on payload. What do you mean by database signature? And because let me get one thing here. HTTP for what? No, remove the tag. Um, because there is one thing called protocol signature. I don't know if that's what you meant, right? Database signature, protocol signature. But anyways, app control uses always the payload, right? Always a common, not a common, a group or a set of patterns that can have that can be in different packets in a specific sequence, right? So it's not only Cincinnati ACK, for example, it can have Cincinnati ACK and more packets in order to detect what's happening. Okay, so it always check the payload, always check more than a packet header. It's not only port. Okay, it's the payload and the port. Because let's say if you're checking port only and someone is tunneling the traffic on port 80, which is HTTP, okay, the app control would detect this as HTTP traffic only, but in fact is some Skype communication or WhatsApp communication or whatever, right? Torrent download that's using port 80, but it's not HTTP. So how can you detect this? Checking the payload, right? And checking the patterns in the payload with the database, right? So it's important when you are using this kind of blade, it's important to check if you are up to date here, okay? It's important to configure a proper recurrence. Like by default it's 2 hours, but maybe for some companies that's too long, right?
Anh
And
ơi,
no, put another. Oh, this is the minimum. Okay, this is the minimum, 2 hours. So you can put
Sao
like daily.
anh
And
chat anh hỏi nó thử là làm
like,
sao nó detect
yo,
được cái application, anh có dùng Encryption không? Có encryption, làm sao nó encryption
so
được
it's
traffic để
always
đọc?
checking more than a header. It's checking the payload, at least for app
Em nghĩ
control.
là nó có mà nó có dùng kiểu
Okay.
proxy à.
So yeah,
Đâu ta?
URL
Để em
filtering, as I
nó
said,
đứng nó đứng kiểu
is
như
the
con
URL.
cái file anh.
Ý
The
là ý là
cloud
F5 thì
has
proxy thì trên
a
client em phải proxy
database, a
rồi.
huge
Ý
database,
là làm
Anh
sao
hỏi gì
để
nữa lại
that they can
ý là how
classify
to inspection
how these
application
URLs,
không? Là được
giving a
rồi.
proper category.
application hả?
Okay,
Đúng rồi.
and that's how it works. That's it, right? The
Application
difference
traffic nha.
about
How to
about
the
app control
checkpoint,
and
how
URL
to the
filtering,
checkpoint
that
đúng không?
app control, as you saw
Inspection.
here, you
How
have
to the
to
checkpoint anh.
download the database. Okay, you have to check the updates. URL filtering, you don't have a local
SSL hay là gì?
database. Okay,
Đúng
what
rồi.
the gateway does is checking
SSL hay là
and the checkpoint
Tại
cloud, what is the
đúng rồi.
category for that particular URL, and then it stores this information in a cache.
Không cứ enter vậy được anh. Vậy được anh.
Okay. So let's say someone tried to access Facebook, right? The gateway is in here. The first thing that the gateway is going to check is the cache. I have this information already. Oh, no, I don't have it. Okay, I don't have it. No. So it goes to the cloud. Okay. And then going to have an answer. Oh, Facebook is social media. Oh, okay. So before giving the proper action, if it's allowed or not, I will add this piece of information to the cache. So if someone else tries to access the same page, right, Facebook is gonna check in the cache again. Do I know this guy? Yes, I know it, right? So I don't need to go to the cloud again to check this. So it's a more dynamic, right? Because this cache, of course, has a time to live. If nobody's accessing that web page for a specific amount of time, that information is removed from this cache, right? There is a question here: how checkpoint inspect application traffic? I mean, it checks the payload. Well, there are some patterns. Okay, let's say HTTP request. In the host header, there is facebook.com. Okay. There is a encoded, what is the name? It's not cookie. Application language. Yes. App language, for example. And it's going to be like UTF-8. And then these are all the headers, HTTP headers, right? These are all HTTP headers. So every HTTP, you have a method, right? That could be a get, could be a post, could be a connect, right? Trace, head. You have a bunch of different methods, HTTP methods, okay? That this method will be here, will be here as well. So this is an HTTP request. This is a get, right? I'm getting the root from this host header, etc. And a bunch of new informations here. Okay. Then there will be a next packet, which is also an HTTP, right? With a different bunch of headers that gives a sequence about this traffic. Okay. And this is going to be checked as well. So all these patterns will be collected and sent, and not sent, and checked against the database, right? So let's say in order to detect Facebook, I need 3 patterns. What is a pattern? Well, it should have this guy, a host header saying facebook.com. It should have an HTTP request and should be a get method. I have the 3 patterns here, right? I'm not saying that's exactly like this, that's how detects Facebook. I'm just using Facebook as an example, right? But you have 3 different patterns, okay? This pattern has a match in the database. Yes, okay, so I'm concluding that this is a Facebook app. Okay, that's how it works in a very macro view. Okay, so it's a collection of patterns, basically. Okay, that needs to happen in a specific sequence and in a specific amount of time. All these details are in the engine. Okay, in the app control engine. Which is very similar to an IPS engine. They use the same principles. Okay, so that's how it works. You can check all the details if you use the debug command. We even do this in the CCTE class, if I remember well, right? Every step that the file is taking to detect this guy, you can, follow up and see what's happening. But it's out of scope here. It's not because it's for troubleshooting classes that you do this. So we cannot see this here. Okay. All right. As you can see, the symbol for URL filtering is the same. Right? Remember how it was for app control? App control, the symbol is different, right? It's usually the logo of the application. Okay. Over here is just categories. That's it. So it uses, again, it uses the cloud to define which category is applied for that particular URL. Okay. And benefits, one thing that they want to stress here, because some people can think that user data is being collected by Checkpoint. It's not, right? Checkpoint does not collect any user data. The only thing that they need is the URL, right? So the guy is accessing www.espn.com. That's all that the cloud, Checkpoint cloud needs, okay? Everything else is not used. And this communication from the gateway and the cloud, the Checkpoint cloud, is encrypted, okay? So even if some personal data was collected, which is not, that information will not be possible to capture, right, by someone else. Okay. And over here is an example. And as you can see, clearly, these are app controls. These are URL filterings. So this is app, this is app, this is URL, URL.
Chỗ này điều gì xảy ra khi mà nó mất kết nối đến
Okay.
cloud rồi?
That's it. Another thing that you can do is what they call custom application. Let's say you have
cloud là
a
cái
custom application in your
con
company,
nó không ra được internet hả?
right? Or you want to create a
là
custom
Giống như
application,
nó ra được
right?
internet không ra được cloud vậy?
để
Because
tí nữa
has
làm lab
some
đi anh,
requirements,
có nhà này
specific
có chỗ này
requirements that is not common. Okay, you can create this application, no problem, right? And you're gonna apply this application name that you're gonna provide to a specific category, right? And you're gonna put the patterns here. Remember the patterns? You can just use a simple pattern like www.yourcompanyname.com, whatever, right? And that's it. Okay. And if you have a very specific application, I mean, more complex, that you cannot do it with this feature, you can open a request on a service request to Checkpoint. And there is a specific area in Checkpoint that they can provide you that particular application name. Okay. Of course, this is a very, very specific thing, but it is possible. Okay. And yeah, these are the actions. I already show you this. These are the user check area, where you can use ask, inform, or block. I show you ask and block. Inform is basically a message. Hey, you are accessing this. Take care. And that's it. It's not, you don't have to accept anything. It's just informing you, right? Hey, you should not access this, but this will be allowed, or something like this. Okay. This is the explanation about the URL filtering database. Okay, there is a cache, as I told you, right? This is only applied for URL filtering, not application control. Application control is a different thing. Application control, there is a database here. Okay. And what if you don't have communication to the cloud? Let's say that you have a problem, or the cloud itself has a problem. It's unlikely because they are different. They are a bunch of data centers which with some redundancies. But let's say you have a problem, okay? A general problem. And the blades cannot work properly. You have what they call fail mode, right? Let's say that the blade is not working. What's going to happen? You can choose
Nó
fail
nói về
open
cái mình hỏi
or
này.
fail close. Fail open means
Sao rồi?
that in case of a problem, all the
Nó đang nói
requests
về cái định hỏi này,
will be
cái mất kết
allowed.
nối đến cloud.
Fail close is the opposite. In case of a problem, all the requests will be blocked, which is the safer option, right? It could cause more problems, right? But at least you are sure that you are not downloading or allowing anyone to download any malware, for example. Okay. So you have this fail mode. What else? If you go to the
Còn nãy giờ
online
có
web
nói cái phần
service,
mà nếu như
right?
HTTPS
The second
thì
option
cần
here,
làm thêm gì
the
không?
fail mode is in general. Now we are here.
Nó chỉ kêu là cái
Let's
HTTP
say your
request đến check theo
database,
cái
I'm sorry,
pattern
the
thôi,
cloud
nghĩa là
is down,
check theo những
right?
cái
Web
HTTP
service is
header
not
á,
available.
nó
Còn
match
nó không
với
có
những
nói gì
cái
tới
thuộc
việc
tính.
HTTPS
You
đúng không?
can
Đúng rồi.
block.
Cái này chỉ hỏi nó thêm
Okay.
cái gì HTTPS
Another
là đúng
thing
không?
is there are two
Cho
types
nó kêu
of
nãy là nếu mà
categorization.
muốn chuyên sâu hơn thì đi khó CCTA đó anh.
Well, how do we
Yeah.
know when there is a problem with internal system? There is a
Kiểu nó chỉ
command
nói cái
called
basic cho mình hiểu là nó chạy được thôi.
wd admin list, which lists for you all the important processes, right? The first sign that you're gonna see that you have internal problem is someone complaining, for sure. Hey, something's not working right. And then you run this command, for example, and it's gonna show you all the processes, and probably one of these key processes will be down, right? That's the first step. Of course, there are way more than this. If depending on the problem, you have to check more details, like FW debug commands, this kind of thing. But the first indication or suspicion that there is something wrong is when your phone calls. Someone is complaining. It's complaining about any access that was working before, it's not working now, basically. Okay. So as you don't know, right, you can just use an automatic fail mode just in case, right? And then you're gonna check based on a user feedback, right? What's happening. Okay. So yeah, I was talking about the categorization mode. You have two different categorizations mode, hold and background. What is the difference? Well, hold means that, let's say, someone is trying to access Facebook. Again, always Facebook or Twitter, whatever, right? And there is nothing in the cache. The cache is empty. So it goes to the cloud. How long it takes to check the category in the cloud? To be honest, some seconds. Okay, it's not that long. But you want to guarantee that you will have all the categorization, right, before allowing the traffic. Okay, so the traffic will not be allowed until you have this answer. Okay, this is what hold does. Okay, so for the guy here, he's gonna see the browser totally blank, right, for a couple of seconds. The page will not open, the Facebook page will not open, okay, until you have the proper answer here. Oh, Facebook is social media. Okay, what is the difference for background? For background, what happens is, while the gateway is checking with the cloud, hey, which category is this guy? The page is opening. Okay, the guy can access Facebook for at least for a couple of seconds, right? Start navigating. And then when you have the answer and this page is blocked, right? You cannot access, the gateway will block the page. And then suddenly when he clicks on somewhere here, the page will be blocked. Okay, so that's the difference between hold and background. Okay, and you can apply this, well, the way it is applied for every page, right? Choosing hold or background here. But you can, if you want, wait a second. You can, if you want, give different behaviors, right? For social media, I will use hold. For everyone else, I'm gonna use background, for example. Okay, so I can use different behaviors for different kinds of access.
Cái background
Okay.
sao ta?
The default is background,
Lời
which means
background
that the
sao đó?
page will start
Tí
open.
để tí ông nói xong em giải thích chỗ này nha.
But as soon as the information is complete about the categorization and the action should block the access, when the user try to do something else, this access will be blocked. Okay, that's how it works. And also we have another problem, okay, with app control and URL filtering, both. What if the user is using HTTPS, which means that the traffic is encrypted? For app control is impossible because app control checks the payload. How can you check the payload of something that is encrypted?
Tới phần
It is
HTTPS.
impossible. Okay, so every vendor nowadays use some HTTPS inspection feature. Okay, what an HTTPS inspection does? Basically, you have, let me see if there is a, no, there isn't. Basically, you have, no, okay, a man in the middle, right? So let's say this is the server. This is the user. The user is opening a HTTPS connection, right? So the gateway gonna open this HTTPS connection. An HTTPS connection starts with an SSL hello. So there will be a hello here, right? And the server gonna send, hey, this is my certificate. Okay, the gateway will get the certificate information here, and it's gonna generate another certificate. Okay, and it's gonna send to the user. Okay, that will cause, basically the gate is gonna be a proxy. Okay, that will cause that you have two different TCP connections. Okay, so this first TCP connection is encrypted with the information of this certificate. The second TCP connection will be also encrypted with this information. But in the middle, let me put blue, in this very particular area here, the traffic is decrypted, which means that the gateway can inspect the traffic and detect the application. Okay? In essence, this is a man in the middle, okay, scenario, right? And if you check here in the Smart Console, you have this HTTPS inspection policy, right? You define the category that you want over here. So let's say
Chỗ này anh mở full screen được không anh Hưng?
Ok.
financial, okay. Financial service, which is very sensitive. I don't want to make an inspection, which means that I'm not doing this process of, oh, it's gone. This process of decryption, right? Because this contains sensitive data, right? But for, let's say, blogs, art, culture, anonymization, browser plugin, toolbars, child abuse. Well, child abuse would be blocked anyways, right? Business economy, critical risk, computers, internet, right? I want to do the inspection. The inspection means that I need to decrypt the data, right? So I'm gonna use a certificate generated by the SMS. Remember the SMS? The SMS has a certificate authority, right? It can generate certificates. So that's how it goes, right? There will be a certificate that's going to be generated, and this certificate will be sent to the user. And that's where is the problem about HTTPS inspection. There are services SSL. There are services that detects this approach.
Anh Hưng hỏi
And
nó
when
thì
it
chỗ này
detects,
làm sao xác
it
định được
closes
cái
the connection.
application đó nó thuộc cái category
The
nào anh
user
Hưng?
will not be
Để
able
làm sao
to access that
cái
his
trang nào để
service.
check trên checkboard đó.
How?
Ok.
Tại
Well,
mỗi hãng có một cái trang riêng.
there are some
Cái
ways. One
URL
of
đó
the
check
ways
bên nào đúng
is
không?
the
Cái
application
application thì phải dùng.
inside the user
Cái
or the
cái
website
URL đó đúng không?
URL chứ.
Đúng rồi URL.
has already the hash of that certificate here, because the server has a certificate, right? And every certificate has a hash. So this hash, the browser knows. Let's say Chrome, okay? But this certificate will never reach the user, because the certificate that the user is gonna see is the certificate generated by the gateway, which has a different hash, right? So when Chrome detects this, hey, this is difficult, this is different. So no, you're not accessing, right? and the connection is blocked, and there is no way to solve this, right? There is no way to solve this. Every HTTPS inspection technology out there of every vendor have the same problem, okay? For example, Microsoft services, Windows Update, Azure, all these guys has this detection feature, okay? There is a question here, how to check URL in category. What do you mean, Hang? When is encrypted? I'm assuming that when it's encrypted, right? HTTPS. Well, anyways, when is URL, you have the URL in the certificate, right? So it gets that piece of information. So let's get an example here. This guacamole communication is encrypted, right? So we can come here and check the certification, or not certification, the certificate, right? You have the common name. So this common name is checked against the checkpoint cloud. Victor just sent the web page. Thank you, Victor. So the gateway gonna get this common name and check against the cloud to check the category. It doesn't need to check the payload, okay? But it's a different way to get the URL, right? But when it comes to app control,
lại
it's
là
different. App control, you
là
really need
Quên nha nè.
to open the
này
payload
nó
to
cứ bảo là lên cloud vậy là bọn
identify
này là
that app.
luôn có cloud á anh.
So you need to
Nó có
deploy it to
local mà.
traffic.
URL là check với
Okay.
cloud em thành
A
nào
little
vậy?
bit, little bit more complex.
URL thì request gửi đến
Right.
thì nó sẽ con
So
firewall
yeah,
nó
if
sẽ
you
đẩy lên
open this
cloud để nó
page
check.
here,
Ok.
Rồi
Bên
sau đó nó sẽ
Local
lưu kết lại.
local là cái
Request tiếp theo
custom
thì
hả?
mình check kết.
you can type a
Local là cái
URL
Mấy-
custom
here.
mấy-
So let's
mình
say
tự đó đó.
Giờ mấy cái hãng kia cũng vậy đúng không anh?
I talk about
Mấy
Facebook.
vendor kia cũng thường là URL là nó check với cloud đúng không anh?
Đúng rồi.
For
Chỗ này
Facebook
social networking.
nó đang vô trong trang web nên nó check.
Okay, so if I use social networking in my rules, blocking social networking, it means that I'm gonna block Facebook. Okay, the whole Facebook. Doesn't matter if it's HTTP or HTTPS.
Anh em lưu lại cái trang nó gửi nha. Cái trang
All right,
urltket.checkpoint.
let's go back to the slide.
Check category.
So you have basically two different types of HTTPS inspection. The most common is the inbound, okay, which is basically what I was saying. The user is trying to access some server that with HTTPS, and you have the gateway in the middle with two different SSL connections. Okay, this is the inbound. Outbound is when you
Được.
has the server, right? You have the server, and you are providing the server as access outside. So you have the gateway. Okay, this is the internet, and someone like your client, your customer, is trying to access your server. Okay. Oh, wait, this is the opposite. I just read the outbound, inbound. Okay, I'm so sorry. This is the inbound, right? This is the outbound. I just saw the white spaces and start drawing, right? Without reading. I'm sorry. So this is the opposite. Okay. So the outbound is the customer, the user going outside, accessing an internet resource. The inbound is someone outside accessing your server, right? So this guy is coming with an SSL, right? It's reaching here. The gateway is going to decrypt this to see if there is any problem or not, and then it goes inside. Okay, that's how it works. And let's put this in practice. Let's do this lab. We have a lab for app control and for HTTPS inspection. Okay. The time for this lab, let's see, 7. We start at 4:06 and goes until 4:63, which is 50 pages, which is 50 minutes. Right now is almost noon, right? It's lunch break. So lunch break with 50 minutes, 1 hour and 50 minutes. So we are going back at 1:50 p.m. All right?
12:15 nha anh
So
em.
let me put here lunch break
Cái chỗ
plus
hold với word browse
labs
lúc nãy rồi anh Hương ơi.
7.1
Cái
and
chỗ này là dành cho phần application.
7
Thì
at
cái hold
1:50.
rồi cái web filtering chứ lộn. Cái web
Okay.
filtering thì
I
nó
think
sẽ
that's
check với
enough
cloud,
time.
còn cái application
It's
control là
a
nó
good
sẽ
practice. You're gonna
nó
check
check
app
local data lane
control,
nha.
web filtering,
Em chú ý
and
chỗ này nha.
inspection.
Sao nói lại thưa lại.
So let's go to lunch. If you want to start the
Con-
lab now in lunch
Con
later, it's
là check với
no
local
problem.
Đợi
I'll
ông
go
nói
to
xong đã,
lunch.
rồi em nói xong.
Have a good lunch for you. Good lab. If anything happens, just send me a message. Okay, I'll be on mute here. See you at 1:50.
Cái chỗ mà application control với cái chỗ web filtering á là nó check hai nơi khác.
At the NAT. In some papers, you can find this as secure NAT instead of source. Okay, but anyways, source is okay as well. I think is even the most correct way, right? The point is, in Checkpoint, they don't use these terms, these names. They use the name hide NAT and static NAT. Hide NAT is what they call dynamic, which is the N-to-1, which in other words is the source NAT, right? Is that classical scenario where you have to provide internet for your company, right? You have a public address here, public IP, and you have your internal network, right? LAN. Okay. And then there's all these people here. Let's say you have, I don't know, 1,000 people, right? They are going out with this public IP. Okay. This is a very common thing. Most of the companies use this. Okay. Static NAT, on the other hand, is the one-to-one approach, right? Usually, this NAT is used for the not for outbound but for inbound, right? You have a server, right? And there's a gateway. This is a let's say a 10.1.1.1 address, which is private, right? And someone need to access your server, but this someone only sees the public IP, pub IP, which could be, I don't know, 200.1.1.1, right? So when the user types www.company.com, DNS will translate that name to this address, and this guy gonna connect to this address, right? Which is the address of your external interface on your gateway. And your gateway must understand this request and translate to the real IP address. Okay, so this is what they call static NAT. okay? One thing that is important to note is the hide net or N2N or ISNet, the name that you prefer, does IP and port translation, right? You need to translate the port here, okay? Not only the IP. For static net, by default, it only translates the IP, not the port. Although it is possible to translate the port if you want, okay? And this is important because you can configure NAT in two different ways in Checkpoint. The lazy way and the not lazy way, easy way and hard way, right? Automatic NAT and manual NAT, okay? Automatic NAT, as the name suggests, you just need to check the object, enable the NAT inside that object. That object can be a gateway, can be a host, any host, can be a network object. Doesn't matter. All these objects have a NAT tab. Let me show you. Where is my lab? Okay. So if you come here, let's get what? Okay, timeout, no problem. Let's go back here. Okay, let's get any object here. AG, whatever, right? This object. You can see there is a net tab, right? If you get a network object, DMZ, you also have the NAT tab, right? Doesn't matter which object, all of them work the same way. You click on the object on the checkbox, right, to enable NAT, and you specify if it's gonna be hide or static or destination NAT or source NAT. Basically, that's what you're saying. So let's say that I need to provide internet access to my DMZ network. So I will put hide because my DMZ uses a private IP address, okay? So let's put hide, and I can choose hide behind the gateway or hide behind a specific IP address. Well, hide behind the gateway means that I'm gonna use the IP address of my external interface in my gateway. Okay, so if I come here, let me cancel this for a while. If I come here to my gateway, and I have only one, you have two, you have the B, right? I have only the A. It's gonna use this guy, the external, okay, because it's already identified. Okay, so let's go back here. Add, hide behind the gateway. If I have another IP address, let's say that when I got my internet access from my ISP, my carrier, right? They provide me not only one IP, but more than one, like 2, 3, 4, right? And I want to go out with a different IP address, right? So let's say 200, 1, 2, 3, whatever, okay? I can do this, okay? As long as I have the IP, right? And I need to specify for which gateway that NAT will be applied, because if I have a lot of different gateways, right, it's important to specify here, because otherwise that NAT rule will be applied for every gateway. And maybe I don't use this network on every gateway, okay? So let's click OK here. And when you click OK, if you come to security policies, NAT, you can see that the rule was created automatically. That's why I told you this is the easiest way to set a NAT, to configure a NAT, right? There are some limitations. The limitation is if I need to do something a little bit more complex, like I need to, not for hide, but mostly for static, I need to create a static NAT translating the port. Okay, let's get this web server HTTP, for example. I want to use a static NAT. And the public IP would be 200, 0, 100, 103. I'm not paying attention if that IP is correct or not. I'm just putting any IP, okay, any public IP, and click OK. When I do this, as you can see here, it just created a rule, right? But it's not considering the port. See, the port is the same. Keep. How do you read this rule, right? This row. You have the original information, original source, original destination, original port. When you have a match with this, I mean, there is a traffic from this IP to any IP and using any port, right? Translate to this IP address, right? Keep the destination the same and keep the port the same, okay? But let's say I need to translate the port, right? I cannot do this using automatic rules. I need the manual rule. And the manual rule is basically in the same page here, but I need to click here and add on the top or on the bottom, okay? What does that mean is if I want to apply my NAT before any automatic NAT, I would use on top. But if I don't care about my automatic NAT, I can use it after these rules, right? And I know that there will be no automatic NAT that could affect my manual NAT rule, okay? So in this case, I can, for example, instead of cloned, I'm gonna use netted. Okay, this is the original one. So I will remove this net automatic rule because I'm gonna use manual, right? So basically what I'm gonna do is if you're coming to, not this one, if you are coming to this web server 200 whatever, right, using port 80, and 80 I don't need to create any object because I already have, okay? Translate this destination to this address 192.168.100.100, but let's say that the port of my web server is not 80, is 8080. And install it on my HW. So, oh, there are two. Why two? It's only one. Okay, now it's good. Okay, so basically, when you manipulate ports, right? Using static net, you need a manual rule. Okay, so sometimes you cannot use automatic net. Of course, for very specific scenarios, but that's where it goes. Okay. Another thing related to manual is that it's totally manual. When I say totally manual, is like, for example, my AG, I'm gonna create a hide using a different IP address. Okay. Oh, it's in here. Yeah. Okay. And as you can see, I put where is the IP? Yeah, I put the IP 200, right? 201. I don't have this IP in any of my interfaces. Okay. But as I specified as automatic net, the system will create a proxy ARP for me, which means that it's gonna create an entry in Gaia associating the public port, the Ethernet port, right, with this IP address. Let me show you this. Well, I cannot show you the entry, but I can show you the proxy ARP, right? So if you come here, proxy ARP, right? So over here, the system will create automatically for me the entry. I don't remember the IP now. Let's say it's this IP, okay? To my external interface, which is Ethernet 3, right? And click save. I'm creating here manually, but I don't have to, right? The system will create this for me, okay? How do I know? Well, in global properties, if you come to NAT, you can see the automatic ARP configuration checked. It is checked by default, which means that it's gonna create that entry automatically for me. So automatic NAT is totally automatic. On the other hand, manual NAT is totally manual. If I do the same in here, right, I just specify a totally different IP address as well, 200, 0, 100, 0, 100, 02. I don't have this IP, okay, in my interface. And this is a manual NAT. So I need to manually add this entry here, 200, 0, 100, 102, right? And then at 3, save it. Now it's correct. The system will not do that for me if I'm using manual rules. So be aware about this when you're manipulating manual net, okay? Which, to be honest, will be in very specific scenarios, okay? Most of your net rules will be automatic, therefore will be easy. Just go to the object, go to the tab, net tab, enable, specify the type that you want, hide or static, choose the gateway, click OK, publish install, that's it, okay? So if you come back here, this is exactly what I was explaining, right? How can you enable NAT? And this is a flow about the NAT, right? So if you see here, this is a hide NAT, which means it's a source NAT, which means it's going to translate the source. Okay, so this is the original, right? As you can see, you have 10.101 and the port 1305. When it goes to the file, there is an automatic NAT rule. It's going to translate the source to 203.0.1.131 and also the port, because source NAT needs to translate the port as well in order to work. Remember that when you use source NAT, you are limited to 64,000 connections, okay? Because this is the limit of your available ports. If you have more than 64,000 connections, you need a second IP address, right? And you make it double. And if you have more than 128, you need 3 IP addresses and so forth, right? But this is a NAT thing. This is a NAT concept. It's not a checkpoint concept. It's NAT. NAT is just like that, right? And when the packet returns, it's going to return to 203, right? It's going to reach the table, and this is the table, right? And it's going to translate it back to the original IP address, right? That's it. That's how NAT works. It's not a big deal. I'm assuming you know the concept. The only thing here is how you apply NAT in the checkpoint. Okay. So yeah, these are the NAT rules. There is a note here because modify source port. There is no need for another rule for reply packets because you have the table. Oh, by the way, if you want to know the table, is FWX underscore lock. No, it's gonna close. Oh my goodness. Go back here, mate. Yes. Let me go back for a while. FWX lock. That's the name of the name of the table. If you want to check the table, just type this command fwtab -t -t from table. Let me put this correct. And the table name, in this case, fwx lock, and I suggest put -f in the end to make it formatted, which is in a way that you can understand. Because if you don't use -f, you're gonna show in an hexadecimal, which is quite difficult to read, right? So yeah, this is the table fwx lock. That's how it controls the NAT entries. Okay. So this is the example I just showed you live, right? The example. As you can see, there are 2 manual rules and all the rest are automatic. Okay. And this is how you set the static NAT. It's the same process. You just need to choose static instead of hide. And over here, you can see there is no mention to ports because by default, static NAT only care about IP. Okay, so this is the destination NAT, right? Usually static NAT is for destination NAT. This is the original IP, right? Reaching the gateway, and then is translated to the private IP. When it goes back, it's gonna be translated, right? Being translated back. Okay, not a big deal. Global properties, I just show you this, right? Usually you don't need to change anything here. Only if you are using manual NAT and you're using proxy ARP, it's a good idea to check this box as well, right? Because you're gonna use both. The proxy ARP for the automatic NAT rules will be used, and also your proxy ARP NAT rules will be in the same place, right? So very short lecture, because NAT is a common concept for most of network administrators, right? You have to deal with this basically daily in any environment. So you have only one lab. It's not two, only one lab. And it seems that is like 30 pages. Let me take a look here. Net translation page start at 469 and it goes until 493, which is 25 pages max, right? Almost 25 pages. So let's put here like 30 minutes. Okay, 30 minutes, and we go to our second break, right? With 10 minutes. So 30 minutes, 40 minutes. Right now is 2:17. Let's round up to 2:20. 30 with this time we are going until 3 p.m. Okay, so let me put here lab 8.1 plus a small break. Okay, return at 3 p.m. right? This lab should not have any problem, but just if something happens, let me know. I'll be here. As always, good lab for you, good break. Give the feedback, thank you. Yeah, only one of you, Jason, it seems that. Oh, okay now, awesome, awesome, no problem. Ah, you scared me. I thought that was something in my microphone. All right, so let's go back here. I was talking about the user management. You have these components that you can use with let me see. Yeah, that you can use with the account, the user account, right? And you can use local user account if you want, which is not exactly recommended because it's not the idea behind the data awareness. Data awareness is to give you the ability to use the same account that the user is using in their domain, right? So most of companies use Windows Active Directory, so why not using the same account, right? To access different resources and to be identified, and therefore you can know which user is doing what. Remember when you talk about app control and URL filtering, that you can see who is accessing what, right? This is the identity awareness, okay? But just to show you, if you come here to the objects, you have the user identities here. Not this one. Where is it? Oh, it is a user. Yeah, let me create a new, more user. Yeah, user. Okay, you can create users, local users, which we are not doing this. Okay, this is old style. It still works, but only if you have very specific needs that you cannot use your AD account, your Active Directory account, you'd use this approach. Okay, so we are not dealing with this, we're not using this, the lab is in there, has nothing to do, but it's important to mention that you still can use, right, this this option. Okay. Yeah, and you can use also time objects, right? This time object is just you know, to, as the name suggests, um, give a specific time to access a specific resource, right? You can make a rule to be available for a specific time frame, like lunch breaks from Monday to Friday. During lunch break, you can allow some specific access to specific sites, right? And you can see here this time objects, which we only have 3, right? The common ones. So every day, right? Off work, but you can create new ones. Okay, no problem. And in your rule, you can put this timed object. Okay, no problem. New. Yeah, can create here the recurrency, etc. Right? Usually you put this in the service. If I remember well, it was in service. No. Oh no, there is a column, time. Okay. Okay. Yes. Right. So you can add this time for whatever resource that you want. It's not exactly related to users. You can use this without any user account, right? But it works well when you are specifying a group of users that can access a specific resources um, uh, for a specific time of the day, of the week, etc. Okay, and now that's the focus, identity awareness. What is identity awareness? As I said, it's a way to reuse your Active Directory account. That's the main focus here, right? In some, where is my sketchbook? Let's open here new whiteboard real quick. All right, it's not exactly perfect, but it works. The idea behind identity awareness is basically a table, okay? Identity awareness uses a table and use different ways to identify the user and get the user information and put in that table. Okay, this table usually you have 3 different pieces of information: the IP, the username, and the machine. Name, right? So when a user, let's go back to the slide real quick. When a user power on the laptop, the PC or whatever, right? And do the logon, the Windows logon, right? A security event will be generated in the domain controller in Active Directory. Okay, so basically the security gateway monitor these events. So it goes from every small number of seconds, okay, to discover if there is any new event. logon event. Okay, and when it detects this event has exactly these three pieces of information: the IP, the username, and the machine name, right? And the user, he just powered on the PC. Is not trying to reach internet, nothing like this. Just log it, right? But that's enough, right? So let's say John. Let's put another color here. Let's say that John, with the not, sorry, this is the IP. John with the IP 10.1.1.2, right? With the PC name John PC, right? Was detected. Then another guy in another computer do the same. Let's say Poe, right? And this guy is 10.1.1.3, and Poe laptop, right? And so on and so forth. Okay. But the point is, there is not only this way to detect the users, to identify the users. If I go back here, you can see that you have at least 8, right? 1, 2, 3, 4, 5, 6, 7, and this last one, 8. This is not exact identification, this is authentication, right? So it's not exact 8, it's only 7, but 8 options, right? Each one of them is dependent of what you have, right? If you have a Windows environment, this is enough. Okay. But some people, they can install, or they want to install, an agent, which is basically a piece of software, right, on the user PC. Why? Because this agent will monitor the PC. Every time that the user do a logon, the agent will know, and the agent will send this piece of information to the gateway, right? So if you want to do this approach, it's not, you don't have to depend on Active Directory. Right? Let's say that the Active Directory is not generating logs or event logs, right? Or not event logs, logon events, sorry. It's not generating logon events. There is no way for this to work, right? That would fail. So you have to guarantee that you can identify everyone. You can choose to use identity agent, but that requires you for install an agent. Okay. If you have a terminal server, it's almost the same thing. Okay, let's say this is your TS server. Okay, TS7, your terminal server, right? And you have a bunch of people connecting to this terminal server to start working, right? The problem is that everyone would have the same IP with different names. So let's say Mary, Joanne, and I don't know, Louis, all three of them connecting, authenticating in the terminal server, and the terminal server IP is 10.1.1.10. So every one of them would have the same IP. Of course, that identity awareness device would be crazy, right? So when you install the terminal server agent in the terminal server, what happens is it adds an extra portion of information, the port. So right now, is the IP is different, but the port, I mean, the IP is the same, but the port is different, right? So let's say the port is 433, 4, 4, 4, 3, 4, 5, and 4, 3, 4, 6. So now you can differentiate who is Mary, who is Joan, and who is Louis. Okay, but that requires you to install an agent in the terminal server. Radius accounting, almost the same thing. Let's say you have a device that's using radius accounting like a Wi-Fi controller. Okay, this should be W. And usually Wi-Fi controller authenticate people using WPA2, which uses radius, right? And you want to get this piece of information from the radius server. So you have your radius server here, right? And you can get this piece of information from radio server, and this piece of information is basically, again, IP, username, machine name. Okay, identity collector is the same as this process here, but instead of the gateway do the monitoring, because in this case it's the gateway that's doing the monitoring, it's not the gateway, right? It's another computer that should be in the domain, any computer. Oops, sorry. So let's say there is a computer here, and you installed this identity collector, and this guy will monitor the domain controller, okay? And it's gonna provide all the table to the gateway, okay? What else? What is, okay. API depends on API. It's there is a specific class for API called CCAS, but basically you are relying on API calls, providing again IP, username, and machine name. It's not covered here. You should have you should take the CCAS class to see this. And remote access is basically VPN. If you have VPN, you are already sending information to that table. So as you can see, you have 7 different ways. Do you have to use all these 7? No. Most of the cases you are here on the first one. Okay. And what if you have a guest on your company, okay, or a partner or whatever? Well, you cannot put him in your domain, right? Usually they are not part of your domain. And that's where you can use the browser-based. The browser-based is basically a portal, right? Where the user can put some information. It's not exactly authenticating with user and password. It could just register themselves, adding their SIM number, their ID, or email, telephone number, whatever. You create this, right? And the guy will be allowed to access. It's just like airport portals. If you are in an airport and you're connecting to the public Wi-Fi, usually there is a portal, right, where you have to add some piece of information, like email or telephone number. It's the same process here. Okay. So basically, you enable the data awareness in your gateway. This is per gateway, right? Choose whatever you want. Usually is an Active Directory. That's exactly what I'm going to do in the lab. And that's it, right? Then the gateway will start monitoring every logon event, and every logon event detected will be sent to that table. Okay. So this is the portal. This one is using username and password, which is the default, but you can change it. You can choose to just collect piece of information like telephone or whatever. Okay. Another thing that's important to note is you can have LDAP with your identity awareness. In fact, it is recommended. Okay. Why? Because this table, it only has IP and it only has IP or network, but it only has the username. What if you need to allow a very large group of users, right? Using this table, it's impossible, right? Like 100 people, right? But they are part of the same department. You cannot use only this. So if you use LDAP along with identity awareness, you can use the group search in your LDAP, right? So everyone that is part of, I don't know, sales department, you can instead of adding the user, you add the sales department only. So every user in that table, right, that is part of the sales department, is member of, that's the correct term, is member of sales department, will be uh, allowed in that rule. Okay, so this is an important thing, and all of this is used using this object access role. Let me show you. So if we go to the lab, we have the access role object. The access role object, let's say finance. Okay. As you can see here, you have exactly the three pieces of information: network, user or groups. You can see here groups, and machine name. Okay. So you create this. Let me put any, right? And get this as a source. So let's say everything from finance to, let's say, web server HTTP using HTTP. Accept and log, not track. Okay. But of course, in order to this access role works, you need to enable identity awareness, right? So how you enable identity awareness? You just need to come to the gateway that you want and check the box. Okay. As soon as you check the box, there will be a wizard with the most used ways to detect users, right? And as you can see, AD query is already selected because this is used by 95% of companies. Okay, so just click next. You specify where is your domain. So in our case is Alpha CP. You put the account that's allowed to go to the to Active Directory to do the monitoring, right? And you specify the IP address of your domain controller, which in our case, I think is this guy. Let me confirm here. Is this guy here, LDAP. Let me just confirm if that is the IP address. Yeah, 11101. Okay. So 11101. Then you click connect. It should work just like this, successfully connected, right? Because you have permissions, etc. And this user is allowed. Click next. Click finish. That's it, right? That's the very basic configuration. Is already working. Okay, it is already working. So you can start doing your testing, right? Just like a log off, log on in any system that is connected to the domain controller. Okay, that's it. And you can add these guys in the access role. So let's open the access role here and see if you can see something. Machines. See, Alpha CP is here. This is my Active Directory structure. Okay, so I can just add, right, the group that I want. I receive an error because I cannot add a group without my LDAP configuration. Okay, I need to add, oops, but I can use any user. So the LDAP is in here. If you need to set an LDAP, is this guy, LDAP account unit. Okay, you just type the name, specify the type of your LDAP. In our case is Microsoft. Okay, is used for Active Directory query. Okay, and you just add who is our guy. It's not in here. I had to add. Oh, this one. Okay, then you type the administrator, the DN, the distinguished name for this, the password, and click OK. I will not fill everything because this is part of the lab. So I want you to do it. Okay. But that's it. After you do this, your DAP is working as well. And you can use groups or users inside of your access roles. So you can have different access roles for different purposes, right? For example, in the slides, there are some examples here. So there is an IT department access role, which I assume that is the group IT, right? So everyone from IT department going to the sales department, right? Using FTP, the traffic will be accepted. So if you have someone from engineering, administration, human resources, etc., will not have a match here, right? Because they are not part from IT. Okay, that's the point. Another example is everyone from sales department going to the web server, sales department web server. Doesn't matter the protocol. Accept. In this case, if IT guy tries, or engineering, administration, etc., also will not have a match. Not having a match will not be accepted. Okay, that's it. That's very simple. The configuration is simple. The concept is simple. The only thing that you need to care about is if you are using, where is it? No, it's here. If you are using all these options, then you have to, check some details. But if you are using Active Directory, which is the focus of this chapter, that's okay, right? Very straightforward, no problem at all. Okay, so you have this last chapter, this last lab. We have still 30 minutes, enough time to do it. And of course, you don't have any time, extra time for any extra chapter. So this is the last chapter for today. you have to do this last lab. Again, it's not a big deal. It's just basically what I did, but with some extra steps, right? You're going to enable the internal awareness. You're going to select AD query, put this piece of information, connect, right? And then do some extra steps to test it. Okay. That's it. And then we are done for today. So you are free to do this lab. If you don't want to do this lab, you want to do later because you have some other things to do, that's fine. If I don't talk with you anymore today, so I appreciate the patience and the time, and I wish you a good rest and see you tomorrow. Okay, I will be mute here until 4, and then I will close the Zoom. Okay, if you need any help or any question, just let me know. Bye.
Anh em có câu hỏi ở chỗ này không?
Nói câu nãy Lợi hỏi là cần hỏi nữa không?
Không, anh nói luôn rồi. Long với Duy với Đạt có hỏi gì không em?
Không anh ơi.
Có hỏi thì hỏi thầy nha, có thầy nha. Em xem lab nè. Sáng mai anh vô là tiếp tục lab tiếp hả ta?
Không, giờ là nó lab tới hết giờ luôn á.
Lab hết giờ, sáng mai vô lý thuyết luôn đúng không?
Mai là vô học á.
Mai là công ty người ta, ngày phải lên nè.
Rồi anh em nói giờ mình out nha.
Dạ ok anh. Để cái nhóm này có gì anh em mình trao đổi nội bộ thôi anh. Ok, thôi out đi anh.